Our topic is transformations following Sadler Mathematics for Unit 2A. It's Chapter 10. There are three main types of transformations. The first we're going to look at is translation, the second reflection, and the third rotation. And then the fourth possibility is a combination of two or more of those. Example 1 involves translation, which is when an object moves up, down, left or right, and we use a vector notation to represent the movement. So let's just quickly revise that. The top number is movement right if it's a positive number and movement left if it's negative. The bottom number is movement up if it's positive and down is negative. Alright, so here's the example, and I've shrunk the question itself so we've got room to actually plot the points. So the shape looks like the one that I've drawn, and it's a good idea to actually represent the points on the graph as well. So the bottom point is at 1, 1, x equals 1, y equals 1, and the other 2 points are also labelled. So the first transformation, 2, 1, means that we're going to move it 2 places or 2 units to the right and 1 unit up. Okay, so there's the shape in red. The bottom point of the triangle is 1, 1. We've added 2 to the x value to produce 3, and we've added 1 to the y value to produce 2, and for the sake of completion I will write the coordinates of that new position. We could do the same for the other points as well. Part 2, we're going to move right 1 and up 3. Example 3, we're moving right 2 units, and this time we have a negative number, -5, so we're translating the shape down 5 units, which will place it down there. And the last one, we're going, both numbers are negatives, so we're moving to the left and down, which will put the object there. When you're dealing with translations, you are adding or subtracting numbers to each of the coordinates. Example 2 further illustrates the idea of translation. You need to be a little bit careful about how you do this, because you're going to make counting mistakes otherwise. So it's a good idea to choose one point on the object. We're starting with shape A, and I'm looking at the top left point, and I'm actually going to draw a line, in this case horizontally left, and then I'm going to count the number of units, and then I'm going to do the same for the upward movement. And when I count these carefully, I get moving to the left is 12 units, so I write -12, and we're moving 4 units up. So the vector for this translation is -12, 4. You can do the same for the other shapes. I've illustrated the second one. Would have been good to use a different colour, but you can see that it's moving 3 units to the right and 4 units up. And in your own time you can go ahead and check these other values. Example 3 introduces the idea of reflection. We're going to reflect a certain object which has an L shape around the lines y equals x and y equals -x, which are plotted as dotted lines on the diagram. These lines will be what is called a line of reflection, which is also sometimes known as a mirror line, because effectively when you reflect an object you're producing a mirror image of the object. Alright, so here's the object that I've plotted, and for the line of reflection y equals x, you can imagine that we are folding the page over along that line, so the object ends up in this position. If the paper was see-through, you would find that one shape is exactly on top of the other one. For the line y equals -x, again you can imagine that you're folding the page over in half, and the shape is going to end up here. For the sake of completion, let's have a look at how each point is moved. These points correspond, as do these, and you can see that each pair of points on the diagram is exactly the same distance from the line just on the other side. One more example. Now we need to correct the example in this case because we also have a rectangle named E, and the question says describe the rotation, but in fact these shapes are not only rotating, they are sometimes translating. So I'm going to make the question read describe the transformation that takes A to B and so on. So let's look at what happens when shape A becomes shape B. If you're looking at a rotation, you want to choose a pivot point, which I've circled in blue. Now I want to use an arrow to illustrate how it rotates 90 degrees clockwise. Again, we use a convention, and the convention is that a clockwise rotation is a negative angle and an anti-clockwise rotation is a positive angle. So this object is rotating negative 90 degrees, and we need to say which coordinate it is rotating about, and that point is 5, 1. Okay, what about shape B? A is moving to C and it's also rotating. The rotation will also be 90 degrees, about 5, 1, and this time we're adding a translation of -3, -4. A to D, this time there's no rotation, but the shape is translating 7 units to the left and 8 units down. Now for A to E, let's consider that the rectangle rotates in the opposite direction about the point 2, 1. So again, we can illustrate the rotation. You can see that that's a quarter of a turn, which is 90 degrees, and we are translating 2 places to the left and 2 places up. So the translation is to -2. So those examples illustrate the 3 kinds of transformation: translation, reflection and rotation, and also a combination of 2 or more of those.